Hey there, Quadratics Made Easy here, and today we're going to be learning about the quadratic formula, when to use it, what it is, and how it came into existence. What is the quadratic formula anyway? It is a beautiful, beautiful, beautiful shortcut to finding the x-intercepts, the values of x, the zeros or solutions or whatever you call it of a quadratic equation. And that is our quadratic formula. Alright, when to use the quadratic formula when factoring a quadratic expression is too hard, long, or inconvenient. When it's complex and it's really hard and you've been trying for minutes and minutes and minutes and you do not have a dime of an idea of how to factor it, just use this formula. Where do we get all that B and all the A's and C's? We get it from this, which is our standard form of quadratic equation. How it came into existence, let us look at that. We can directly derive it from the standard form. So derivation, that's the process of derivation. Oh, it's not pretty much of a long process, but you do need to know one thing for that. You need to know the standard form and you need to know how to do the process known as completing the squares. So we set y equals 0 as we are finding x-intercepts, and to do that we have to set y equals 0. Why do we have to set y equals 0? Because the x-intercept is a place where the parabola, it intersects the x-axis, and when it intersects the x-axis, at that point the y coordinate or the value of y has to be 0. So that is why we set y equals 0. And then what we did over here in the second step, this step over here, is we divided the entire equation by the coefficient of x squared by a. We did that because that's more convenient, and it makes it shorter and it's easier to handle. We have to do that if we start this method with a, then it'll become a bit of a trouble, because in the end we're gonna have to square root, and we cannot square root ax squared and get a perfect square, or even get anything near a perfect square. So here we have we take this term plus c by a, the constant term, to the other side by subtracting from both sides, and this is negative c by a equals x squared plus b by ax. Then we add something, we add to both sides positive b by twice a whole square. What are we doing here? We're completing the squares. We're trying to create a perfect square right over here, and to do that we have to add this term, that is the third term in the perfect square, and to this side too. As we added on this side of the equation, we have to add on this side of the equation too to balance it. And over here, the next step, we just made a common denominator and open the bracket. So that gives us b squared minus 4ac divided by 4a squared, because 2a squared is 4a squared. And over here we just open that bracket. And the next step, b squared minus 4ac by 4a squared equals x plus b by 2a whole square. Why did we do that? Because we were preparing to make a perfect square term over here, and we just made it a perfect square right here. We expressed it as a perfect square. And over here, this step we square rooted both sides, so if we square root, the power of 2 gets cancelled, so this leaves us to x plus b by 2a. Over here we have plus minus root over b squared minus 4ac by 4a squared. Why is it a plus minus? Let us look at this. You see, 9 root over 9, it could be positive 3 into positive 3. Root over 9 could also be negative 3 into negative 3. Therefore, it is more appropriate to write root over 9 equals plus minus 3, because it can be plus 3, it can also be minus 3. That's why we gave the plus minus over there. In the next step, we move over the b by 2a term to this side, because we're trying to get x on one side. We want this formula to look like this, and to do this we have x on only one side. We can't have b by 2a on this side, so we put it on that side. That gives us x equals negative b by 2a plus minus root over b squared minus 4ac by 2a. And that is the quadratic formula. So that is a short derivation to the quadratic formula using the method completing the squares right away from the standard form of a quadratic equation. Thank you.